Today I'm delighted to welcome Torben Noergaard from the Mærsk Mc-Kinney Møller Center for Zero Carbon Shipping. The Mærsk Mc-Kinney Møller Center for Zero Carbon Shipping is a not-for-profit, independent research and development center looking to accelerate the transition towards a net zero future for the maritime industry. With a global portfolio of partners, the center drive and facilitate the development and implementation of new technologies, build confidence in new concepts, and mature viable strategic ways to drive the required systemic and regulatory change to accelerate the transition of the maritime industry. As Chief Technology and Analytics Officer at the Center, Torben Noergaard is accountable for positioning the maritime transition into context of the global energy transition and translating gaps and opportunities into actionable developments for ecosystems. Torben, very welcome and thanks for making some time today.
Thank you, Joachim. Thank you for inviting for this opportunity. Looking forward to our dialogue and debate.
Tom, we are recording this ahead of Asia Pacific Maritime 2026, where future fuels and real-world deployment questions will be on many agendas. So I'd like to use our 10 to 15 minutes to focus on what decision makers can actually do beyond headlines and targets. So from your perspective, where does the shipping industry realistically stand today when it comes to future fuels compared to stated decarbonization ambitions?
Indeed, and yes, I do look forward to joining the Asia Pacific Maritime in March in Singapore and debate these topics, and this is a great venue to warm up for that session. When we look at the industry, then, and you look at the media picture today, then it would appear as if we are sort of resetting a little bit and coming to a pause. I think I want to challenge that perception a little bit, and I think the best way to do that is to look a little bit backwards to get sort of the right baseline in terms of how far we've actually progressed. And the industry actually has progressed quite a lot and made rather significant moves in terms of preparing for the energy transition. There's been a lot of testing. There's been a lot of it around new fuels in the global fleet. It's been enabled, again, through testing. It's been enabled through the adoption of dual fuel technologies on board the vessels. So a significant portion of our vessel and a significant portion of the new builds we see right now coming in and being ordered has that ability. Also on the enabling frameworks, we've seen developments like the FuelEU Maritime, and there's quite a lot of activities around national and regional efforts to build similar frameworks. And most importantly, we had the agreement last year in April around the net zero framework, which is a global framework starting to create an investment framework for the maritime industry. That being agreed with a huge majority in the International Maritime Organization. I recognize also that framework has yet to be adopted, so we had the postponement last October, and we still have a process ongoing around that. So that's kind of also what needs to be taken into the picture when you look at maritime and its development. But there's no doubt, if you take this over, let's call it a 5-year horizon, there's been significant developments both in terms of technology adoption and preparedness, and in terms of developing these frameworks. And then lastly, I want to anchor, which I think is something also we will have as a common theme throughout this dialogue, that if you look beyond shipping and look at the world at large and the energy transition going on, then also in spite of current sort of media attention to climate policies being sort of pushed a little bit aside in terms of energy security, energy resilience, actually investments into transition technology continues to rise year on year. So the world is transitioning. So the big thing around shipping is that it needs to continue to ensure that it remains relevant for the global transition, which is ongoing at pace, accelerating year by year.
I think that a reality check is really helpful, and it also implies that the hard part is not picking a winner, but understanding the trade-offs by vessel type and trade. So let's please unpack this. What are the most important trade-offs decision makers need to understand when comparing different future fuel pathways across vessel types and trades?
Exactly, and there are lots of trade-offs, and the first thing to bear in mind as we move into the energy transition is that complexity for decision makers in the maritime industry is increasing. We look into a more diverse fuel landscape, and we look into a more diverse regulatory pattern, and we look into a more diverse opportunity pattern in terms of the energy efficiency measures you can put on board the vessel itself. And all that needs to be integrated uh, in the strategy of the decision makers so that they continue to have line of sight to continue to pave a way where they are consistently able to navigate the increasing complexity and the sharpening regulation that we expect will continue to happen, thereby step by step improving their greenhouse gas intensity, lowering their greenhouse gas intensity as sharper regulation and customer pull will start to mobilize. So how can they do that? Well, we start to see some pathways developing in terms of how you integrate that technology on board your vessel. And it's important to integrate that so that you don't become too deterministic in your investment strategy. So we see a gas pathway developing, where today we have methane-based vessels that probably to begin with will start on fossil-based methane, LNG, and move into bio-based. But actually, a rather significant portion of these vessels now start to operate with a term called ammonia ready. Ammonia is still a vector that is out there and is growing in importance and something that we see coming towards us in the future. We have a liquid pathway where you have fuel oil, but also that can be matured through bio-based drop-ins. We see methanol-enabled vessels that also that operate on liquids, and we see ethanol starting to play a role there. So again, need to ensure that you have a line of sight to becoming less and less lowering your greenhouse gas intensity. And then on top of all that, we see electricity, direct electrification coming in as an energy vector that wasn't apparent just a few years ago, but driven by other industry sectors and growing in intensity in terms of the attention it requires. So direct electrification initially for shorter routes, but also as a hybrid solution, something that needs to be thought into the decision making process of vessel owners.
If those trade-offs are the decision metrics, then the next constraint is whether the fuel can actually show up at scale. So how decisive are fuel availability, port infrastructure, the global supply chains in determining which fuels will actually scale?
Fuel will scale not due to shipping, but due to markets across industries. The energy industry has always worked across energy sectors, and actually operates with much larger volume than any individual sector can deliver. So we need to look for synergies across sector. We need to understand where are the market makers for the different energy sectors, and who and which regions will drive which types of infrastructure. With that critical understanding in place, we will understand where in the world will which molecules be available at which point in time. And already now we can start to see a few examples where very likely energy vectors will be driven by market makers and by areas that will drive infrastructure to that. So, other than the existing energy vector, which is natural gas and oil products, then you could look at ammonia, where outside shipping, you have the power industry starting to drive that energy vector through coal-firing power plants in the Far East. You see a trade pattern erupting across the Pacific Ocean. You start to see now ethanol being an energy vector relevant for shipping. It's an energy vector that already exists going into automotive transportation, but as that industry, automotive transportation, land transportation, start to electrify, and as we start to understand granularities around sustainability aspects of production of bioethanol, it all of a sudden starts to become relevant for shipping because there is surplus capacity and we understand those sustainability contexts. Lastly, also, I would point at direct electrification, which is something that is growing and also a theme that we will be debating at the Asian Pacific Maritime Conference in March, because it is a rather important vector and very new to the shipping industry. Also, already now being introduced into many sort of electricity grids as an alternative to fossil-based electricity production. But also we see a significant growth in that being driven by an entire new sector, data centers and AI, that projects to grow to something that consumes the same amount of energy as shipping and aviation together within a decade. And the infrastructure associated with that will be significant and drive in select countries, the US, the Europe, but also in Asia, access to electricity as an energy vector. And all of that is something shipping needs to adapt to and needs to take stock of, because these energy vectors will be relevant for shipping as first wave energy supply sources with lower greenhouse gas intensity than the current fossil-based alternatives.
Yeah, that makes clear why no single actor can solve this alone, and which brings us to the center's role and the collaboration piece. So from the Mærsk Mc-Kinney Møller Center's perspective, what role does cross-industry collaboration play here in enabling future fuels, and where do you see the biggest coordination gaps today?
Exactly. And the answer is almost given based on what we spoke about just a minute ago. It's absolutely essential. So shipping is not an island, is how we usually phrase it. It needs to integrate and create synergies with other industry sectors as we develop the enabling infrastructure and these energy vectors. So coordination is essential. We need, shipping needs to be part of a bigger energy network as it is today. So some of the gaps that occur and that will enable shipping to be relevant in these new energy systems are topics around standards, around certification, around how you measure and adopt into lifecycle assessments. Standards, if you take the direct electrification vector, then you need to have a standard on how you adopt power from shore and bring that onto the vessel, how you deal with electricity. Now, that's actually a tricky thing, because electricity don't have global standards. It's unique from region to region across the world. But ships, they travel across the world, so they need to have a global standard. So there are things to talk about there to prepare and enable shipping to plug into that energy system. Same around the new energy molecules. We need to have coherent understanding about what is the specification of those, how do we handle them from a safety aspects, how do we certify the origination of these fuels, and how do we measure their environmental and emissions impact. So all of those are gaps that are currently being worked on and formulated, and all have the ambition to, again, mobilize these energy vectors, make them ready for the maritime industry, doing it so that it integrates into the global context.
Given those coordination realities, let's end with a forward-looking but pragmatic view. Looking ahead, which fuel pathways are most likely to scale over the next 5 to 10 years, and where should the industry be a bit more cautious or realistic?
Yeah. And that picture has actually, become clearer over the last couple of maybe months, actually, I would say. And again, electrification is something that is growing rapidly as we see the cost of electricity coming down in the grids that service, and we see the cost of batteries really, really taking all projections by surprise and being available at lower cost and higher energy density as we saw. So that's going to play a role for short and mid-sea shipping to begin with. And that's going to have an effect on shipping, on how it develops. And that's mainly being driven, as we spoke about before, by a new sector driving through the need for more electricity and electrification of society in general. As a consequence of that and other aspects, we start to see that the very high focus we had on hydrogen derivatives, power to X molecules, that we had a couple of years ago, is something where we should act with a little bit more caution, because we see that development being deferred. The focus is now on direct electrification. So the wave of power to X molecules entering the mix, we see that happening a little bit later than we initially saw. Instead, we see maybe the equivalent molecules but stemming from biogenic origination, whether that being methane, methanol, ethanol, or biooils, with drop-in capabilities, is something that we see as a first wave, both from a cost perspective, being supported by the regulation we see being put in place, is something that you know, in first small scale application to take us through the first 5-10% of the decarbonization journey is something that will play a significant role inside the next 5 to 10 years and is mobilizing fast. I'll also mention ammonia. Ammonia is something that actually remains on track. It takes a little bit less media attention these days, but it's not because it's falling behind. What we start to see now is the initial commercialization of ammonia solution. We start to see clarity around safety, around crew acceptance. We have the engine ready and available, and something actually you can order now. And the signs of vessel is starting to hit the wall. We also start to see that actually production of low emission ammonia is starting to occur. There was an announcement of a green corridor container feeder supported by Yara, just announced the other day. And again, we see this trans-Pacific trade of low emission ammonia happening, driven by power plant industries. So ammonia is very much on track, something that, still at scale, not for tomorrow, something that comes as a second wave and definitely in the next decade. And then lastly, I want to mention ethanol once more. Also a new thing, something that a couple of years ago we disregarded from the maritime industry due to availability and due to sustainability issues. But as we now can nuance our view and have a more granular view on sustainability, and as ethanol actually now has surplus capacity, it looks also to play a role in the short and midterm, in particular for the methanol-enabled vessels that struggle a little bit to get cost-effective low-emission methanol out of the supply chains. So I think there are multiple vectors in the short and midterm that now start to crystallize as obvious solutions, and circling back to the very beginning of our discussion, that needs to be considered in the boardroom and amongst executives that strategize around this. How do they prepare their fleet to operate with flexibility inside the array of these implementers?
Tom, thank you so much. I mean, that was refreshingly practical. And if our viewers take one thing away, I think that's few decisions are a portfolio of constraints and risk, and not a single headline choice. Thank you so much for your time today.
Thank you for the opportunity, Joachim. Thanks.